All right, everybody, we're going to get started. Good morning. How's everybody doing?
Good, sir.
So the way things are going to go today is going to roll through a PowerPoint. Depending on questions, it lasts about 30 to 40 minutes. And then I have a video of the Pierce representative who is not here today. That video is about 25 minutes. And then after that, we'll take a break. And then I will take half of the group to engine 5, and the other half will be going to engine 7. Okay? So it's a picture of our new Pierce Puck fleet right here. It's been a long time coming. As you can see, there's 7 of the Type 1s are there. The 8th one was engine 1. It was already on the road to California when this picture was taken. So going through the lineup of the apparatus, if you guys aren't aware, I'm just going to review everything. We have 16 vehicles, well actually 17 that are going in place right now. The 16 that we're discussing right now are the 8 Type 1s, engine 1, 5, 6, 7, 8, 9, 11, and 12. And the 2 tillers are truck 1 and truck 3. The straight truck, which is truck 13, 1 brush truck, which is brush 1, 2 water tenders, water tender 4, water tender 5, the 2 squads, which are already in service, squad 1 and 2. And then the units we have in process still are truck 2. We're working on the PO with Pierce regarding new truck 2. The foam tender, the process has started on the foam tender. That's a new WASI grant purchase item. And then if you guys aren't aware, engine 13 is going to become engine 10, and due to the door height at station 10. So station 10's got a 10-foot pin, 10-foot door. So these units are 10 feet, which you'll see later on in the PowerPoint. So we have, we're going to have figure out what we're going to do with engine 10 when they need a new engine. Okay? So Pierce, a Puck, stands for Pierce Ultimate Configuration. Years ago it was pump under cab, then they changed it to Pierce Ultimate Configuration. These units are 2018 Pierce Aero XD cabs. Their DD13 stands for Demand Detroit. DD13, the engines are 470 horsepower. They're producing 1,650 foot-pounds of torque, and they have 1,500 gallons per minute pumps. You guys could sign in, please. And shut the door behind you, please, Tom. And the truck companies are 525 horsepower, 525 horsepower with 1,850 pounds of torque. So big change on this compared to what we're used to on how the fire pump's driven. This fire pump is driven off of a Repto drive. Repto stands for rear engine power takeoff. It's driven off of the 1 o'clock position of the rear of the engine. And the reason why they run it off the Repto is because it can handle more torque and more horsepower than a regular PTO. So it can handle up to 240 horsepower and up to 480 foot-pounds of torque. So talking about the Repto, and we'll see this today. Here's the back of the engine. There's the 1 o'clock position. And then when this engine's turning, the Repto's spinning. And the driveline spinning. So there's a driveline that goes from the Repto, this driveline connects to the Repto, which connects to the back of the engine. So this driveline, every time the engine's spinning, the driveline's spinning. Then when we put it into pump, then it'll activate over here through the clutches. When you're up and around working around the engine, looking at it, doing your Saturday checks, there's do not step tags all over the place. Be careful not to step on that because the driveline's there. And when you're up there, you want to step on it because it's an easy spot to step on. So just be cognizant that that drive shaft is there, okay? So looking at the pump, if you can just imagine what I just showed you, the driveline's coming in from the back of the Repto here to the coupling here, and then you have your clutches inside the pump. When you put it in pump, it activates the clutches, and then it'll spin the impeller. Here's the intake side of the pump is on the back side, and then here is the discharge side of the pump on the front side. So if you look at the pump, you can see how it, like here's your volute, you can see how it kind of sits down, and then if you can just imagine the frame rails of the engine that come down here. So the pump actually sits down in the frame, and then it comes up over the frame rails, and it comes down around the frame, and then your discharges are on the outside. Here's another shot of the pump, just a different view. And again, the drive line's coming in here to that coupling. And then you have your clutches and your gears, and it activates the impeller. Questions on that? Okay. So how to engage the pump. So I'm trying to get across to everybody, just try and remember remember that Pierce Puck pumps pump in neutral, and say that 4 times. So Pierce Puck pumps pump in neutral. So we want you to spot for the incident, apply the parking brake, place the unit in neutral. It has a fail-safe in it. When you hit the parking brake, it automatically drops into neutral, but go ahead and put it into neutral, okay? And then to turn on the pump, there's 2 switches down on the left-hand side, down below the steering wheel, and you have your pump switch and your foam switch. So you can turn your pump switch on, and then you can turn your foam switch on. Or you can just turn the foam switch on, and if you hit the foam switch, it'll activate the pump as well. So it's a one-stop shop. And what I'm telling everybody is, I want you to flow foam. I want you to flow foam on vehicle fires, trash fires. We're setting the foam systems at 0.1%, the lowest percentage. And if you just hit the foam button and it fires the foam pump up, or it fires the foam pump and the pump up, then at least we're getting everything moving in that foam system. So we've had an issue with foam for many years, and we want to make sure that these foam systems are being exercised. So you have a green light will appear. The yellow light will appear. It says OK to pump. A green light appears on the pump and on the foam switch. That shows that they're engaged. You're going to hear a change in pitch, which is the pump's going to activate. We have puck gauges on top. You'll see pressure on the puck gauges, and your water will show up as well, how much water you have in your tank overhead, and then your throttle will go dead. So again, Pierce Puck pumps pump in neutral. Put it in neutral. And then here's your pump engaging switches. So the first one is the pump, second one is foam. Like I said, you can turn the pump on and then turn the foam on, or if you just hit the foam switch, it will activate both. And overhead are your pressure and your water puck gauges. And that's on all of our units that have the puck pump. So prior to starting, you're going to get out. We had a little bit of a lengthy conversation with the manufacturer regarding the pressure governor. This is an FRC pump boss that Pierce had built and made it specific to their pump panel. So it functions the same way as our pump bosses do right now. So the way we have it set is that the governor is going to come on automatically in PSI mode, and then you can toggle between RPM or PSI. You have to have 15 pounds of pressure on the back side. You've all seen the video and the tutorial, right? That was sent out. So you have to have pressure on the back side of that. What's that? You guys didn't get it? I think so. Okay. Well, then we'll make sure we get it out. If you didn't get it, send me an email and we'll get it to you. You have to have pressure on the back side of that pressure governor for it to actually work. So if your pump's dry, you're going to go out there and you're going to go throttle it up, and it's not going to throttle because it's going to start flashing low warning. It won't do anything. And then if you want to change between pressure and RPM, you need to throttle down below 20 psi. However, if you are in a situation where you're drafting, and then once you have a good draft and you're flowing water and you want to switch from RPM, because you should be drafting in what mode? RPM. And then if you're going to switch to PSI mode, you hold the control button down here for 3 seconds, and then it'll toggle between RPM and PSI. And then again, when should you guys be in RPM versus PSI? Drafting and relay pumping. They're saying relay pumping as well, because which we don't do much, but if we have like 4 units in line, that the pressure governor is trying to catch up to the next unit. If you've ever worked off of those units, they high idle and low idle a lot with the pressure governor. So they want us in RPM mode except for the pumping unit, and it should be in pressure mode. So mobile pumping, these units, obviously they're Repto driven, so we can mobile with these units. Same as everything else, you're going to set up for mobile pumping operation. You're going to put your foot on the brake, you're going to put it in gear, and then if you're going to mobile pump, then obviously if you're mobile pumping like off the jump line or off the pressure line, then your brake is going to be your controlling device, and your foot throttle is going to be your pressure device. So just like the old brush truck, and then you're just going to have to power brake through your pressure to get enough pressure out of your line. However, this has a safety feature in it that if you get enough speed when you're mobile pumping and you hit second gear, it'll kick out a pump. So these have T-handles on them, as you saw, and they have automatic and they have manual mode. So put the T-handle into manual mode and then put it in first gear if you're going to mobile pump, and then you can mobile pump off out of first gear and then power brake through that, and then it won't shift into second. So, emergency pump operation. So we've had a variety of ways to switch our KMEs and our E1s into emergency pump operation, and some of them are rather involved. This unit, you go to the pump panel, there's a little door, you open the little door on the pump panel, which we'll show you today, and there's a switch, a red switch there. And you flip the switch, and it goes in the pump. Okay? Pretty simple, but keeping in mind, Pierce is saying not to use it unless we necessarily have to, and only use it as a last resort. It bypasses all other safety features on the unit, and when that's in emergency mode, that it just goes direct into pump, and you won't have any other safety features. So let's say you're in emergency mode and you're mobiling, it'll shift through the gears, so you just got to be careful. And then when you go to close your operator panel down, and if you go to close that door and you forget that it's in emergency mode, that switch is going to hold the door open, so it has a fail-safe in there, because then you'll look and you go, oh, why is that open? And then you'll see that it's in emergency mode. So only use it as a last resort, very last resort. So foam system. I'm asking you guys to flow foam. If you get on a structure fire, it's in 0.1%. You can leave it in 0.1. If you need more, go out to the pump panel and then bump your percentage up. Or keep it at 1%. Fire gets knocked down, turn the foam pump off, right here, the on-off switch, turn it off, and then flush the line. So basically this foam system, it has up and down for percentages, and then you scroll through, it has a fill stop as well. It has a prime button and an on-off switch. So you have foam in your front jump line, you have foam in the two lower cross lays, you have foam in the pressure line, and then the two rear discharges. So anything coming off of the pump, there's no foam, and the deck gun, there's no foam.
Question.
Yep.
You said after we're all done we should flush the lines. How long are we talking?
Till the foam's gone. Okay? So we're not flushing the foam pump. We just turn the foam pump off, and then you flush your lines. We leave the foam system primed all the time. We don't flush the foam system. Okay? So going over the Husky 3, what we have now is a Husky 3. It's a Pierce product. It's 3 gallons per minute of Class A foam, or B, whatever system you have. We have a Class A foam. We're not carrying Class B foam on our units. 20-gallon tanks on the Type 1s, 15 gallons on the on the trucks. It's electric over hydraulic. It's single point injection, and it works most accurate between 75 and 250 psi. So just going through as a 3 gallon a minute foam system, if you're running 0.3, you can get 1,000 gallons a minute out of it. 0.5% is 600, 1% is 300, and then 3% is 100 gallons a minute. Okay, so we get on that. We're going to flow foam. It's going to be set at 0.1%. If it's a vehicle fire and you're flowing a little bit of foam and the vehicle gets knocked down, just turn the foam pump off and then start flushing the line. And by the time you're ready to pick up, the line should be clear, and you guys should be ready to pick up hose and go. Okay? And we're setting it at 0.1, so if you need more, bump it up. And then so here's the valving, and Mike from the shop, he's going to go outside and he's going to show you guys how to do this as well. So in that little door, I was trying to explain to you where the emergency button is, the emergency switch. There's a valve. Can you guys see that yellow handle back there? Can you see that? So there's a valve in there. And basically, and then on your engineer's side pump panel, or the driver's side pump panel, there is another valve here that says draft in tank. So if you guys want to fill the tank, You put it in draft mode, you have your pail here, you put it in draft mode, and you take the switch and you put the valve up. So basically you're going to come from the ground, out of the pail, and you can fill the tank up that way. If you want to go up on top and fill it up, you can do that as well. Okay? So, and this system will also allow us to flow foam from the pail, bypass what we have in the tank, and go directly to the pump. So you can keep it in draft mode here, and then you put the valve down towards the front of the truck, and then you can put your pickup in the foam tank, or in the foam bucket, and then you can actually flow foam directly out of that bucket onto the fire. Okay? And then if you're going to operate directly off of the system itself, you just put this switch in tank mode, which is all the way down, and you put that switch in forward mode, and then you're ready to function off of this system here. All right, guys, so how long do we prime a 1,500 gallon a minute pump?
How long it takes? With these ones?
Yeah, with these ones.
You have to try the air primer? Or?
We got a Trident air primer. Okay, so I'm going to show you guys a couple of videos. And so we have a Trident air primer. And basically he's going to discuss all about the Trident air primer. I'm just going to show you some.
Hi, I'm Mark Davis, president of GBW Associates, home of GotBigWater.com, and we're here today to take a look at the Trident automatic air primer. At GBW Associates, one of our specialties is water supply operations, and we try to show new and innovative products out there that are really going to help the rural firefighting, in fact, any firefighting community. The automatic air primer is by far the gold standard in today's primer from our perspective. It has a lot of features to it. In this video clip, we're going to take a look at the primer itself, talk about a few of the features. Then in subsequent videos, you're going to see a lot of different practical applications. So let's start. First of all, it's made of brass and stainless steel. There's no aluminum used, so it's going to be highly resistant to any type of corrosion. Only weighs 9 pounds. It has no electric motor. The thing that I find most interesting about it is there are no moving parts inside this device at all. Unlike a rotary vane or a rotary gear pump, there is nothing in here to move. It's supplied by air from your air brakes, so it comes from a reliable supply. Your brake system has to have a reliable supply. It's fed by your air brake system. That's where it gets its air from, which of course is fed by the compressor on the motor of your fire truck. It'll handle up to a 27-foot vertical lift. It will automatically drain, so when you have it installed and you stop using it, it automatically drains. There's no worry about freezing. There's only air going to the primer. There's nothing else. There's no lubrication inside. There's nothing inside that needs to do that. As I noted, no moving parts. Comes with a 5-year warranty. It's low cost compared to the cost of replacing rotary vane primers over time. Doesn't have to have an electric motor or clutch or belt drive. It is simply air, compressed air, passing through and drawing the water up into your pump. In other words, drawing the air out, creating a vacuum in your pump. Talk a bit about installation. Installation, we can do new installations or retrofits, or Trident can, whoever your service company may be. About half the time, any high location will work. We'll show a video clip of a fire truck that has one installed. We want it high in the pump box so it gets all the air out of the top of the pump. Control panel is nothing more than a switch on the pump panel, no pull handle, nothing like that. And it has the ability to go to gated intakes, multiple gated intakes. On a retrofit, doesn't require any wiring from the battery. It can be hooked up right to the power supply that lights the lights on your pump panel, or any other power supply that goes to the pump panel. Less space than a regular primer. I can install it in the station if I have a mechanic in my firehouse. There's been a number of those installed like that. and it'll go on any fire pump. It doesn't matter what brand manufacturer. Let's take a closer look at the primer. Really just a few basic parts. This is where all the good stuff happens in here. Inside here are Venturis. Air comes in here from your air brake. It passes through to Venturis and exits here. While it does that, it draws the air out of your pump. So this goes to your pump. This is your Y strainer. This would be fed from your pump, and basically what happens is it primes the pump this way. This is a solenoid connection tied into your pressure switches. Your pressure sensors are what basically tell this device in the automatic mode when and when not to prime the pump. It does have multiple air inlets so that I could have a number of suction intakes gated so that I prime each one individually. So we're going to move outside. We're going to take a look at some practical applications of the primer, take a look at an install, and then show some of the ways that it can be used. We're back here in Carroll County, Maryland with Winfield Community Volunteer Fire Department using engine 142 again. I'm Mark Davis, GBW Associates, home of GotBigWater.com, and we are looking at the Trident Auto Air Prime at what we would call a high lift. We have 3 lengths of 6-inch hard sleeve coming off of this bridge down to a box strainer in the stream. What we're going to do is driver operator at Scott Dayhoff again. He is going to prime that pump, or he's going to engage the pump, run it up to 1,000 RPMs. It's a 1,500 gallon minute pumper using 6-inch hard sleeve. And once he hits that auto prime, we're going to start a timer and see what it takes to get this thing primed. RPMs are up. Got it at 1,000, and it started. You can hear the air primer. So we'll try to see, we can see the water coming up in the tube. There it is. It's on its way to the coupling, almost at that last coupling. Almost there, almost there. All right, so it made it to that coupling. We're at the 24-second mark. Now it's coming up closer to coming over top of the bridge. Hard to see in the sunlight. Maybe that's a better picture. So there it is right there. We're at 39 seconds. You can see some air bubbles, so that's going to be coming probably from one of them couplings. Notice the driver operator's touching nothing on that pump panel. We're at 57 seconds. Air primer's still working, automatic feature. Remember, gravity's trying to pull this water back. Now it's going to start coming into the pump. We're at 1:16. We'll start to see discharge pressure on this pump once the pump fills itself up. 1:28. Notice our vacuum is at about 15 inches, 14, 15 inches. That equates to about 16 foot of lift from the surface of the water to the eye of the impeller. 1:43, 44. We should start to see some changes occurring as the pump casing fills up. You can see still has some air bubbles coming through. And here we go. You hear changing the motor a little bit. Now that pump is primed. 2 minutes, 6 seconds for 16 foot of lift. We'll have him go ahead and charge the discharge. Charge that 3-inch line just so we have some water flowing. You should hear the air primer kick in maybe. There it is. Now it's good to go. It kicked in and took an air bubble out. So a really good example of how the automatic air primer can work at a high lift. I would offer that you need to think about doing this with a rotary vane primer and having to prime for 1.5 or 2 minutes to get your water all the way up to the pumper. Most likely you'd smell that primer smoking or burning, and you'd see it smoking. So from the perspective of this, the high whiff does not appear to be a problem for the Trident automatic air primer.
So that air primer they were using was one of the first generations, and it had a single discharge. Ours has 3 discharges on it, so it's the most up-to-date air primer, and your unit should prime in 30 to 45 seconds. So what I'm asking everybody to do is at about 45 seconds, if you're priming, to start checking your system if you don't have prime at 45 seconds, okay? But you can see that you can let that thing run until you're out of air, you know, but if you're not getting a prime, obviously there's something wrong. So it talked about an automatic switch. We don't have automatic switches on the pumpers of the trucks. The only one we do have it on is on the brush truck. It has an automatic switch on there. You just put it in automatic mode, and then if you're drafting and if it loses air, it'll just fire back up and turn back on. Okay? Questions on that? That's good? Okay. Spotting for incidents. So what I want to try and get across to you guys is that these are a little bit different. Again, pull past the incident, get your captain 3 sides, leave room for the truck company if they need truck company operations, or if it's a mid-rise or a high-rise and or they need to put the truck, the ladder up. I'm asking to leave at least a minimum of 15 feet from unit to unit, maybe even 20 if you need to. Everything's coming out of the back of the rig, so you're going to be working out of the back of the rig. So the ladders aren't coming down off the side, curb side anymore. They're coming out of the back. So you're going to open the door, and then you're going to slide the ladders out. And you want, 1, you want to be able to get your ladders out and your pike poles if you need to. And 2, we don't want to be blowing out, you know, the person's windshield behind us or trying to get the unit out or get the ladder out. And then the other thing too is that what we don't do and what we need to start doing and considering is spotting your pump panel. We don't spot our pump panels now, right? So just think about if you're going to a vehicle fire on the freeway, you have a vehicle fire on the right shoulder, engine compartment's involved, and how are you going to come up and spot? You guys are going to come in and you're going to spot like this, right? Is that correct? That way, in case somebody comes to hit you, they're going to bounce into traffic. We've taught you guys that. So if you're pumping that fire, where are you at?
Bad side.
Right. You guys got to start thinking about where the pump panel is and spot your pump panel. So you might want to come in and then maybe angle the opposite way, put your pump panel on the opposite side so you can see what's going on. And then if something does happen, you're gonna plow them in the guardrail or put them in the guardrail, but at least you know you're gonna be safe. Okay. All right. So terminology. When we get outside, you're gonna see that there are several pump panels on the unit. The one on the driver's side is called the driver's side pump panel, and then the one on the passenger side is called the passenger side pump panel, and then the one where all your gauges and valves are is called the operator's panel. So when we refer to pump panels, we refer them to driver's side, passenger side, and operator's pump panel. I was going over this. I know training's already gone over this with you guys, but we have 3-inch hose on our units. What units has 3-inch hose?
Yes.
And the water tenders. So the brush trucks, the OESs, and the water tenders all have 3-inch hose. And the conversion factor, anybody hear a conversion factor about 0.6? Okay. So years ago we had 3-inch hose that we ran up our ladders to flow water, and it had 3-inch couplings on it. So the conversion was 0.6. These are 3-inch hose with 2.5-inch couplings, so the conversion factor is 0.8. GPM setting, structural and other related fires, 150 gallons per minute. And our high-rise hose packs, which we'll see outside, are 200. And then the front cross lay is 1.5-inch double jacket with a wildland nozzle on it, and then the front jump is 1.5-inch double jacket as well. Over the side rescues. What we're trying to get away from is wrapping the duals and the tires for your anchor point. We put anchor points on these units, and I'll show you outside. So we want you to spot for the incident, set the brake, chalk the downhill side of the unit, lock out, tag out the apparatus, put a cone in the seat, put the cone on the floorboard, and provide a safety officer. Obviously, you're going to request the rescue, and then You're going to put this pin in, and it's just like a truck receiver. It slides in and it has a pin on the back side. It's a 9,000 pound anchor. On the engines and the truck companies, it's all 9,000 pounds until you get to truck 13, and the way that's built, it's only a 6,000 pound anchor on truck 13. Just some additional tools. When was the last time anybody's used a Hebert clamp on a fire? Okay, so we purchased 2.5 to 2.5 inch Y in case you have a need for a Hebert style clamp. So you have this 2.5 inch to 2.5 inch Y, and that all the appliances are the same. And then this porter tank, it's a 2,000 gallon porter tank that's going to be on the water tenders. And the idea is if we're on a 2-3 day wildland fire in the river bottom, you can drop the porter tank. You can use it to draft out of. The water tender can set it up. They can drop their load into it, fill it up, and then it has a discharge port over here, and the water tender also carries hard suction on it. So you can connect the hard suction from the tank to the pumping engine. They can draft out of it, and you can round robin with the water tender. The front end and the tiller steering are all independent suspension. So this suspension was built by Oshkosh that they use in the military. It's military grade for when units are out in Iraq and dealing with all the military stuff that we have to deal with over there. So it's a heavy duty, independent front suspension, and you kind of got to be careful because the units ride they're very comfortable. If you haven't driven the rescue ride's comfortable as well. We didn't put air ride on the back because if you put air ride on the independent front suspension, it made the unit feel squirrely. So you have a full spring pack on the back and then the independent front suspension on the front.
Proprietary, proven technology, custom built for firefighters who rely on Pierce custom chassis. TAC4 independent suspension maximizes ride quality and steerability while maintaining the feel of the road. TAC4 was originally engineered by Pierce's parent company, Oshkosh Corporation, for off-road military and aircraft rescue missions. Built for severe duty, TAC4 silences potholes, railroad tracks, speed bumps, and crowned intersections. It increases ride quality by up to 340%, reducing stress on occupants and vehicle components. Compared to standard leaf suspension, TAC4 keeps tires on track for unequaled handling and performance, with up to 10 inches of suspension travel and independent wheel movement. With the highest cramp angle of any independent front suspension in the fire industry, you can safely, effectively, and more quickly maneuver into strategic locations at the scene. The independent suspension accommodates larger 17-inch front brakes that transfer weight faster to the front wheels. Stop quicker, up to 23% sooner, and dramatically reduce the risk of accidents and brake wear. With its higher rated front axle, departments can add more features without exceeding gross vehicle weight restrictions. Critical system components are easy to access in service, and uptime is at an all-time high, with routine maintenance and inspections provided by Pierce's vast service network. Pierce also offers TAC4 independent rear suspension, which takes the same military-grade performance and applies it to the rear axle. Departments in need of extreme mobility can take advantage of TAC4 T3, which combines the benefits of TAC4 independent rear suspension with a 100% mechanical rear steering system. Respond quickly, perform safely, lead confidently with TAC4 independent suspension, only from Pierce Manufacturing.
These rigs are 10 feet tall, so we went from, our units right now are about 9'6". This is a 10-foot overall height. We're gonna have to figure out what we're doing with the flags, because I don't know if we can put a 2-foot flag on the 10 feet, and so there's a picture of truck 1. With truck 2 and truck 3 are gonna be the same. So just real quick on the ladders, if you guys aren't aware, heavy duty ladder, 107 feet long. It's a 750 pound tip load, flowing 1,500 gallons a minute. Okay? and it'll go negative 10 degrees below grade. So much bigger, much more sturdier, more GPM, more weight than we're dealing with now. Okay, it's a really, really nice ladder. But when the trucks get here, we're going to do truck training specifically on the trucks. This is truck 13. For those that don't think it's coming, it's here. It's coming. I put it right there. I took that picture, and it was cold, man. Let me tell you, it was snowing and everything. So that's the ladder lit up at night. All the ladders are the same. Looks like a Knott's Berry Farm ride. So ride's nice. It can maneuver. It's and I think out of all of the rigs, this is going to be a very, very, very nice unit. They're all nice, but this is going to be a really good unit. Here's brush one. Brush one is 500 gallons of water, 750 gallon per minute pump. It's a high pressure pump. It's the same pump that's in brush 7. So it's not a two-stage pump. It's a high pressure pump. It just has a one extra volute that allows us to boost the pressure off of that pump to make it a high pressure pump. Because I've heard people talk about that it's a two-stage pump. It's not a true two-stage pump. It just has an extra little impeller on it to boost the pressure. Water tenders. These are made out of Florida, built out of Florida. So it has a 1,000 gallon a minute pump, holds 2,100 gallons of water. It has coffin boxes on top. Those are actually, they built them wrong. They had to bring them down. They were too tall. The overall height wasn't correct, so they had to fix that. And then it has a dump valve on the back. That, if you can see that here, it can swing around, and then it pulls out, and then you drop your porta tank, and then you can just dump right into it or pump into it or however you guys figure it out. But you also have the turret in the front to mobile. And it has 2 crosslays on it as well. Your doors are electronic. Okay, so then there's a code on the side, and the numbers on are 1, 2, 3, 4, just the way you have it written. So if you lock the door and you get stuck, just go all the way down, 1, 2, 3, 4, 5, 6, and then back to 1. And that unlocks it. And then if you forget the door code, in the air cleaner intake, you open that hatch up and there's a button in there, and then that's another button. You can unlock the doors with that, okay? So, right. The inch and 3/4 crosslay. The inch and 3/4 crosslay, when you build this out for the Metro Pack, you need to go from the nozzle to the bend. You need to start at 66 inches, and by the time you're done, it should be at 73, right, Danny? And then we're going to overhang the flat load about 4 inches on each side. And that gives you the opportunity to grab it, and then it's not hitting the door. So we played with that, Station 1 guys played with that, so we can get that perfect.